Welcome to the Deep Dive. Today, we're going to be looking at array programming. And this is something that's super fundamental to computer science, especially if you're getting into data science, machine learning, all that good stuff. And you're a CS student, so I think this will be right up your alley.
Yeah. Array programming is really all about applying operations to like a whole bunch of values at once instead of doing them one by one.
Okay, so why is that so important? I mean, I know that computers are fast,
Hmm.
but is there like a deeper reason why this matters so much?
Yeah, for sure. It's not just about speed. One of the pioneers of this whole idea, Kenneth Iverson, he said that mathematical notation, like the way we write math, often does a way better job at expressing complex ideas than most programming languages. And array programming is like trying to fix that.
Oh, that's interesting. So it's not just about crunching numbers faster, but also about expressing these complex computations in a more intuitive way.
Exactly. It's about making the way we think about problems match the way we write code. So, instead of getting lost in the weeds with individual values, you start thinking about like chunks of data, kind of like vectors and matrices from math.
I see. So it's a shift in thinking as much as a new set of tools.
Hmm.
To help our listener really get to it, can we like jump into an example of how array programming is different from the old way of doing things?
Of course. So let's say you have to add two arrays together. In a language like C, which, treats each value separately, you'd probably use those nested loops, going through each element and adding them one by one.
Oh, yeah, the nested loops. Not exactly known for being elegant.
Right.
Can you give us an idea of what that C code would actually look like?
Sure. So imagine two arrays, A and B, both have like 5 elements. The C code to add them together would be something like this.
Okay.
For int I uns evil, I5, I++. Basically, you're telling the computer to go to each position from 0 to 4, grab the values from A and B at that spot, add them up, and store the result in a new array, C, in the same position. It works, but it's kind of long-winded.
Yeah, that can get pretty repetitive, especially with bigger arrays. How would a language that's built for arrays like Fortran handle this?
Oh, in Fortran, or a similar language that's all about arrays, you could do the same thing in just one line. C equals A plus B. That's it. No loops, no going step by step. You treat A and D as single things like you do in vector addition in math. You can really see the difference, right?
Right, yeah. The Fortran code is way more straightforward and just feels more natural, like how we would write it in math. But you were saying earlier that it's not just about making the code shorter. How does this affect the way you solve problems?
Well, when you start thinking in terms of arrays, you naturally start seeing patterns in your data that you might miss if you're focused on individual elements. Like in image processing, you can represent an image as a 2D array, and then you can apply filters or transformations to the whole image at once, which is way faster than doing each pixel one by one.
That makes sense. It's about taking advantage of the way the data is organized to solve problems better. But wouldn't this kind of approach be limited to like special languages that were built for this?
That's a good question. While there are languages that are specifically designed for arrays like Fortran and APL,
Huh.
even languages that weren't have started to incorporate array features because they're so useful.
Really? That's cool. Can you give us an example of a language like that which has adopted these array ideas?
Yeah, take Python, for example. It's a very popular language, but it wasn't originally designed for heavy number crunching. But then came NumPy. It's a library that adds a really powerful array object to Python, and now it's like the tool for scientific computing in Python.
So it sounds like this array way of thinking is spreading throughout the programming world. It's not just a niche thing anymore. But before we go on to specific languages, I wanted to go back to what you mentioned earlier about Kenneth Iverson and his ideas about mathematical notation. How does that connect to the power of array programming?
Yeah, that's a really key insight. A lot of array languages are made to be like math, letting you express complex calculations in a clear and concise way that's like mathematical notation.
That's really cool. Do you have a specific example of this in action, something our listener who's just starting computer science can really grasp?
Sure. Let's say you're trying to solve a system of linear equations, something you'll probably see in a linear algebra course. Linear algebra is all about vectors, matrices, and how they work together. In MATLAB, which is really popular in engineering and science, you can solve an entire system of equations in one line of code using what's called the backslash operator. It's basically doing matrix left division, a concept straight out of linear algebra.
So you can write the solution in a way that's almost exactly like the math notation, instead of writing out a bunch of loops and if statements.
That's awesome. Could you show us what that code looks like?
Yeah. If you have a system of equations written as x equals b, where a is the coefficient matrix, x is the vector of unknowns, and b is the constant vector, in MATLAB, to solve for x, you just write x equals ab.
Wow.
It's that simple because MATLAB is built around arrays. It understands matrices and vectors as like basic building blocks so you can work with them directly. If you tried to do the same thing in a language that doesn't have that, it would be a lot more code and a lot more complicated.
That's amazing. I can see how that would not only be faster, but also help you avoid mistakes because you have less code to write. It's like speaking the language of math to the computer.
Exactly, and that's what I'm getting at. Array programming isn't just about speed, it's about making your code clear, elegant, and making the way you think about the problem match the way you write the code. This has been so insightful. I feel like I have a whole new understanding of what array programming is all about. Now I'm really curious to learn more about the different ways it works in different languages. What are some of the key languages that our listener, as a new computer scientist, should know about?
Okay, that's a great transition. Let's dive into some of the languages that have really embraced array programming and how their unique approaches have made them good at what they do. So let's talk about some specific languages. We already mentioned Fortran, a classic example of a language made for number crunching and working with arrays. It's been a workhorse in science and engineering for ages, and it's still going strong.
Yeah, Fortran definitely seems like it stood the test of time. What about languages that are a bit newer or that focus on different areas?
Right. If you're interested in data science, statistics, and making cool visualizations, R is a really good option. It was built with arrays as a core concept from the beginning, and it has tons of packages for all kinds of specialized tasks.
I've heard R is super popular in fields like bioinformatics and finance. What makes it so well suited for those kinds of things?
It's the combo of powerful array handling, built-in statistical functions, and a really active community that's always making new tools. R makes it super easy to load, clean, analyze, and visualize data, which is essential in those data-driven fields.
That makes a lot of sense. Now, what about MATLAB? We talked about it briefly before with linear algebra. What are its strengths and weaknesses?
MATLAB is like the go-to for anything involving numerical computation, matrix manipulation, and algorithm development. It has a really intuitive way of working with arrays and matrices, and its visualization capabilities are amazing. It's used extensively in engineering, physics, finance, you name it.
So MATLAB is more for the engineering and scientific computing side of things. You mentioned it has some weaknesses, though. What are those?
Well, MATLAB is a commercial product, so you got to pay to use it. Also, while it's awesome for prototyping and numerical work, it might not always be the best fit for large-scale software development or situations where performance is absolutely critical.
Okay, I see. So we've got Fortran for the tried-and-true numerical stuff,
Mm.
R for data science and statistics, and MATLAB for engineering and scientific computing. That covers quite a bit. Are there any other languages our listeners should know about, maybe ones that take a different approach to array programming?
Oh, yeah, there are. APL and J are two really interesting languages that push the boundaries of array programming with their super concise syntax and really powerful array operations. They use special symbols to represent these operations, which can make them look a bit cryptic at first, but they let you express complex calculations in a very compact way.
Wow, they sound like secret codes for mathematicians. I imagine there's a pretty steep learning curve, though. Are they used in any practical applications, or are they mostly for academic stuff?
While they're not as widely used as languages like Python or R, APL and J have found niches in finance, data analysis, and even game development. Their ability to manipulate data in really abstract ways can be a big advantage for certain types of problems.
That's fascinating. It seems like there's an array programming language for just about every preference and purpose. With so many choices, though, how does a computer science student like our listener figure out where to begin?
The best way is to think about your interests and the types of problems you want to tackle. If you're into data science, R is a great starting point. For engineering or scientific computing, MATLAB is a solid choice. And if you're curious about the more unconventional side of array programming, APL or J might be worth exploring.
So it's about finding the right tool for the job. But no matter which language you pick, the core ideas of array programming are transferable, right?
You got it. Once you get the hang of working with arrays as first-class objects, thinking in terms of vectorized operations and taking advantage of how your data is structured, you can use those principles across different languages and contexts.
That's reassuring. It means that learning array programming isn't just about memorizing a specific syntax. It's about developing a powerful way of thinking about problem solving. You mentioned something called the abstraction penalty earlier, though. Can you explain what that is and why it matters?
Sure, the abstraction penalty refers to the potential drawbacks of using high-level abstractions, like those fancy array operations, compared to more low-level approaches. While array programming can make your code cleaner and more concise, there might be times when those high-level operations come at the cost of performance.
So it's a trade-off between elegance and efficiency. Can you give us an example of when the abstraction penalty might be a problem?
Yeah, definitely. Imagine you're working on a system that needs to react super quickly, like a high-frequency trading platform or a flight control system. In these cases, squeezing every last bit of performance out of your code is crucial. Using a high-level array operation that does a bunch of computations behind the scenes could cause a tiny delay that might be a big deal in those time-critical situations.
I see. So even though array programming is generally a great approach, it's important to think about the context and the specific needs of the problem you're trying to solve. Sometimes a more detailed approach might be necessary to get the performance you need.
Exactly. It's about understanding the trade-offs and picking the right tool for the task at hand. Array programming is a powerful tool, but like any tool, it's most effective when you use it wisely and understand its strengths and limitations.
So as we wrap up our deep dive into array programming, what's like the one big thing you want our listener to take away from this?
I think the most important thing to remember is that array programming is as much a way of thinking as it is about specific language features. It's about looking for ways to write your code that take advantage of the structure of your data and match the way you think about math.
So it's about seeing the forest for the trees, like the overall patterns in the data, instead of getting stuck on individual data points.
Exactly. It's about knowing when you can treat a group of values as one thing and do operations on them all at once. This change in how you see things can lead to code that's shorter, more elegant, and often more efficient.
That's a great point. As our listener goes further in computer science and learns different programming languages, what should they look for when it comes to array programming?
I'd say pay close attention to how each language handles arrays and matrices. Some languages, like Fortran and APL, were built with arrays as like a fundamental concept. Others, like Python and C++B, have added array capabilities through libraries like NumPy and Armadillo.
So it's about understanding the different ways that array programming works in different languages.
Right. Every language has its own way of thinking about and working with arrays. For example, R is really focused on statistics and data analysis, while MATLAB is great for numerical calculations and engineering applications. By exploring those differences, you can get a better understanding of what each language is good at and choose the best one for your needs.
That's really helpful. It's not just about learning the syntax, but also understanding the design decisions that shaped how each language handles array programming. Any last bits of advice for our new computer scientists as they start exploring array programming?
I'd say don't be afraid to experiment. Play around with different languages, try out different array operations, and see how you can use these concepts to solve the problems that interest you. Array programming is a powerful tool, but like any tool, it takes practice to become really good at it.
Well said. This deep dive has been really eye-opening, and I'm sure our listener will find this information really valuable as they continue their journey in computer science. Thanks so much for sharing your expertise with us.
It's been a pleasure. I hope our listener is excited to explore the world of array programming and discover its power and elegance.
And on that note, we'll wrap up this episode of The Deep Dive. Until next time, keep exploring, keep learning, and keep diving deep into the fascinating world of computer science.